Hi, in this video I'm going to go through a number of examples of trigonometry using sine, cosine and tan formulae in order to find a missing angle or a missing side. I'm going to start with missing side, move on to missing angles, and then towards the end I'm going to go through a couple of examples of worded questions and a challenge question at the very end. First of all, let's remind ourselves of the formulae. So the word we need to remember is SOHCAHTOA, where S stands for sine, O for opposite, H for hypotenuse, C for cos, A for adjacent, H for hypotenuse, T stands for tan, O for the opposite, A for the adjacent. So that is my first formula. So means sine of the angle is O over H. So the sine of the angle is opposite divided by the hypotenuse. K will mean cos of the angle is A, the adjacent, over H, the hypotenuse. And TOA will mean that tan of the angle is O, opposite, divided by the adjacent. So they are the formulae I'm going to use to find missing side and then a missing angle later. So in the first example we've got the angle 37, that line 4 meters, and that line is what I'm looking for. Now we need to be able to label the triangle. That's probably the most important part. Now the across from the right angle is always the hypotenuse. That's always H. Across from the angle given, or the angle I'm looking for, is the opposite. And the side next to the angle is the adjacent. So here we've got the hypotenuse and I'm looking for the opposite. So I'm going to write my word, SOHCAHTOA, and I'm going to take all the H's because I've got the H, I've got the hypotenuse. I'm looking for the opposite, I'm going to take all the O's. And now out of the three, which one has got two ticks? This formula here. So that's the one I'm going to use. So that means that sine of the angle is opposite over the hypotenuse. So sine of the angle, sine of 37, is opposite, which is x, over the hypotenuse, 4. Now time both sides by 4, and that will end up with x equal 4 times sine 37 degrees. I'm going to put that in a calculator and get an answer of 2.4 meters, rounded to 1 decimal place. And that's your final answer. Second example, first of all we need to label the triangle. Across from the right angle we said is always the hypotenuse. Across from the angle given is the opposite. The side next to the angle is the adjacent. So I'm going to write my word, SOHCAHTOA, and I've got the H. I'm looking for A. That's the one I'm going to use because that one is the one with two ticks. C stands for cos. Cos of the angle is equal A x over H, 8. Time both sides by 8, and that will end up with x equal 8 times cos 64. Put that in a calculator and I get 3.5 centimeter, rounded to 1 decimal place. Last example on finding the side, I've got a right angle triangle. Across from the right angle is the hypotenuse. across from the angle given as the opposite, next to the angle given, or the angle I'm looking for as the adjacent. I'll write my word. I've got the adjacent. I'm looking for the opposite. That's the one I need to use for this one. So T stands for tan 42. Opposite, which is x, divided by the adjacent 2.7. Times by 2.7 both sides. X equal 2.7 times tan 42 degrees. Put that in a calculator and I get 2.4 meters rounded to 1 decimal place. Now the next 3 examples will be about finding the angle. This example here we've got, this is the angle I'm looking for. That's 7 meters and that's 9 meters. Let's label the triangle to start with. Across from the right angle is H, hypotenuse. Across from the angle given, or the angle I'm looking for, is the opposite. And the one next to it is the adjacent. Write the word. I've got H. I've got O. That's the one I need to use. S, sine of the angle, is O over H. So sine of x is O 7 over H 9. Now, in order to get x, we need to get the inverse sine of 7 over 9. I'm going to put that in a calculator. In order to get inverse sine in a calculator, you need to press second sine or inverse sine. And the answer here is 51.1 degrees. Second example, we have this line is 4.3 centimeter, that one is 5.8 centimeter, and the angle in between is the one I'm looking for. So label the triangle. Across from the right angle is H. Across from the angle given, or the angle I'm looking for, is the O. The one next to the angle is A. So write my word. I've got A and H. That's the one I need to use. So now cos of the angle is A over H. So now cos of the angle is x, is A, which is 4.3 over H, 5.8. So the same way I've done there, x is equal inverse cos of 4.3 over 5.8. And my answer is 42.2 degrees. Last example, we have 3.4 for this side, 2.3 on this side, and that's the angle I'm looking for. Label the triangle. Across from the right angle is H, across from the angle given as O, or the angle I'm looking for, and next to it is A. SOHCAHTOA. I've got A, I've got O. That's the one. T stands for tan of the angle as O over A. Tan of the angle as O over A. To find x, we'll need to get the inverse sine of the inverse tan of 2.3 over 3.4, put in the calculator, and we get an answer of 34.1 degrees, rounded to 1 decimal place. Now I'm going through 2-worded example. The first one is: a boy flying a kite lets out 200 meters of string. If the string is taut and makes an angle of 72 degrees with the horizontal, what is the height of the kite? Here is the boy. He let 200 meters of string, and here is the kite. It also says that the angle from the boy to the kite, so straight down one, makes 72 degrees. So here is my right angle triangle, and they want to know what is the height of the kite from the ground. That's where the boy is. So that's what I'm looking for. That's what I've got. So I'm write my word. Need to label the triangle. So across from the right angle is H. Across from the angle given, or the one I'm looking for, is the O. And the one next to it is A. So yeah, I've got the H. I'm looking for O. That's what I'm going to use. S stands for sine of the angle is O over H. So sine of 72 is OX over the hypotenuse, 200. So times by 200 both sides, and we will end up with x equal 200 times sine 72. Put in a calculator and we get an answer of 190.2 meters. The second worded question is: a ladder is 15 meters long. The top rests against the wall of a house and the foot rests on level ground 2 meters from the wall. Calculate the angle between the ladder and the ground. Here is where I am. This is the ladder, 15 meters long, and this is the wall. So that's the wall. This is the ladder. And this is me. So I am 2 meters away from the wall, and the ladder is 15 meters. What is the angle that my ladder makes? So I'm going to label the triangle. This is a right angle triangle. Across from the right angle is the hypotenuse. Across from the angle I'm looking for is the opposite. And next to the angle is the adjacent. I'm going to write my word. I've got the H. I've got the A. So that means that this is what I'm going to use. C stands for cos of the angle is A over H. So cos of the angle, which I don't know, is equal A over H. In order to get the angle, I need to get the inverse cos of 2/15. Put that in a calculator and we get 82.3 degrees, rounded to 1 decimal place. One very last example is this question. It is a harder case. We've got a right angle triangle, and let's label. Across from the right angle triangle is the hypotenuse. Across from the angle given is the opposite, and next to it is the adjacent. We write our word. I've got the opposite. I'm looking for the hypotenuse. That's the one I'm going to use. So S stands for sine of the angle is O over H. Sine of the angle, sine of 49, is O, which is 15, over H, which is X. Now I say this is another question because X in this case is the denominator. So what I need to do an extra step. What I'm going to do first is time both sides by X. So it will be X times this is equal 15. And now I'm going to divide by sine 49. So x is equal 15 divided by sine 49. Put in a calculator and I get that x is 19.9 meters. I hope this helps clarify some aspects of trigonometry. If you want any extra clarification, if you've got any extra question, a specific question, please ask and I will try to answer. I can make extra videos. Thank you.